So page 458, number 40. Okay. So they give you this graph, and 1, 2, 3, 4, 5, and 1. All right, so it's going through that, it's going through that, and it's got an asymptote going through this. And it wants you to come up with the equation. So it's going through the point 5, 1, and going through the point 2, 0. And it has an asymptote going through x equals 1. So your form of your equation will be y equals log base b of x minus, I don't remember what letters we used. I'll say c, just, right? Where c is going to be your asymptote. And so we've got y equals log base b of x minus 1, since your asymptote is going through 1. And then what you're going to do is use any point, but not the one that's on the x-axis, because you'll get something that's always true. You're going to plug in the point 5, 1, which means you're going to plug 1 into y and 5 into x. And then you can solve for your b. So that means you've got 1 is equal to log base b of 4. And then you'll go around the world, go b to the power of 1 is equal to 4. So b to the power of 1 is equal to 4. And so if your base is 4, then your equation is y equals log base 4 of x minus 1. And that is what will give you the equation of that log function. Okay. What was that one? Can you do the graph from the quiz? Graph from the quiz. The graph from Okay. So it's the quiz. The quiz graph was number 8, I guess. I'll see another graph on here. Okay. Where they're asking you to graph k of x. K of x is the same thing as f of x. They're just using a different letter. Natural log of 4x plus 3. And so what I would do, we have you find those 3 things before it because those are important. The x-intercept you're going to find when y is 0. So you'll plug a 0 into y and get natural log of 4x plus 3. Now, natural log is log base e. So I'm going to rewrite it like that so that it's more obvious that you're going to go around the world, and it's an e to the power of 0 is equal to the 4x plus 3. And e to the 0, anything to the 0 power is 1. So that means you'll have a 1 is equal to 4x plus 3. Subtracting the 3 will give you a negative 2 is equal to 4x. And so x is equal to negative 1/2. So that's your x-intercept. Your y-intercept is going to be when x is 0. And solving for y. So you'll have y is equal to the natural log of 4 times 0 plus 3. And so it's equal to the natural log of 3. That's what I would write as my answer because that's an exact. In order to graph it, though, we need the decimal. So what's the natural log of 3? Natural log of 3 is approximately 1.1 because it's 1.098. So I'll know how to graph that. And then your asymptote The asymptote equation is always going to be this part that's after the log, that guy. When is that equal to 0? And so you'll go 4x plus 3 is equal to 0, or x is equal to -3 over 4. Okay, so now that I've got my x-intercept, my y-intercept, and my asymptote, and I know this is a logarithm, right? A log equation, and it's also a log equation base e, and e is about 2.7, so it's going to take on the exact same shape as a log base 2, right? And so I'm going to go to the next slide. And we had an x-intercept of 1/2, so I'll say that's 1/2, and so then that makes that -1/2. So there's -1. Here's -1/2 as your x-intercept. Your y-intercept would be about here, and then we had an asymptote equation of -3/4. We really need to change these numbers because they're not friendly. Pretend like that's going through y equals negative, or x equals -3/4. And then it looks like the rest of the log equations where it increases and it goes through those 2 points and then curves up. Excuse the messiness of that, but that's what the graph should have looked like. That's your point 0, well, truly the natural log of 3. And then that point there is the -1/2, 0. And it's an increasing function. Your domain is all the values greater than -1, or -3/4, and I guess we could say that your domain is going to be x is greater than the asymptote, -3/4. Your range, I'll put this asymptote, but just in case, is all real numbers. It's going to hit everything. What else would we ask you on that? But all right, there's that one. Last problem on the quiz. Okay, it's going to take some time. You want all of the word problems. Holy crap, really? All of them? I'll do the last one and then you guys, and then you can go from there. Okay, the last problem on the quiz was the Newton's Law of Cooling one. So quiz number 17. And it says, Jackson's walking his dog on a cool 50-degree evening, blah, 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 blah. Okay, so we've got Newton's law of cooling is that the final temperature is equal to the surrounding temperature plus the initial minus the surrounding times e to the -RT. And what they gave you was, they gave you that the surrounding temperature is 50 degrees. Blah, 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 that the first reading is 82 degrees, and then 30 minutes later, it's 77 degrees. And so what they've done is they've given you a final temp and an original temp in order for you to figure out the cooling rate. So the original temperature was 82 degrees. The final temperature, because between the two, in that 30-minute time, was 77, and the time in between them was 30 minutes. I did it as 0.5 of an hour. So if you did it 30 minutes, you'll get a slightly different rate. Well, you'll get a very much different rate than me, but it doesn't mean you did it wrong. Anyway, so we plug all these in. 77 is equal to 50 plus 82 minus 50 times e to the -r is what I'm trying to solve for here, and then times 0.5 is what I used for the time. So that'll give you a 27 is equal to 32 e to the -0.5r. And then dividing both sides by 32 gives you e to the -0.5r. You want to solve for r, so you're going to take the natural log of both sides. And what that does is cancel out the e on the right-hand side, and you're just left with negative 0.5r. If you multiply both sides by a -2, that'll undo that. So -2 times the natural log of 27 over 32 is equal to r. I would store this in your calculator. It ends up being about, what, 0.33979. So if you round, at least go to 4 decimal places, right? Or you could store it, and that'll give you an even more accurate thing. I'm going to just be lazy and go, okay, r is about 0.3398. By going to 4 decimal places, my answer should be pretty right on to what the actual answer is. All right, so then now that we have our cooling rate, now what we're going to do is plug these back in using an alive temperature and a dead temperature to figure out how long the body was dead. Now, you can use either one of these. It's the same thing as that activity on Friday. It doesn't matter. But they tell you that the first reading was taken at 6 p.m. And so I'm going to go ahead and use that as my original temperature. And then, so that's going to be my dead temperature that I'm going to use is 82. So we're going to do all of this again. Plugging into Newton's law of cooling, which is final temperature is surrounding temperature plus the original minus the surrounding times e to the negative RT. All right, so with this time I'm going to use that the surrounding temperature is still 50. The final temperature is that dead temperature that was taken at 6 p.m. Say at 6 p.m. And then the original temperature is an alive temperature, which they gave you normal body temperature is 98.6 degrees. And then the R I'm going to use is 0.3398. All right, so we plug all of those in, and that'll give you 82 is equal to 50 plus 98.6 minus 50 times e to the negative, I'm using that rate, 0.3398, and then t is what we're solving for this time. Subtract the 50. This would be a, what, 48.6 e to the negative 0.33898 t. Divide both sides by 48.6. And that'll give you e to the negative 0.3398 t. And again, to get that variable out of the exponent, you need logarithms. And I'm going to do log base e, which is the natural log. 48.6 is going to equal the negative 0.3398 times t. And then dividing both sides by the negative 0.3398 is going to give you that the time is approximately, I got 1.2298, and remember I changed it to half of an hour, and so this is hours. Now, of course, if I would have done minutes, it probably would have been easier, huh? Because then I wouldn't have to figure out how many minutes have passed now. Well, poop. Well, oh well. How do you convert this to how many minutes? You're going to go, this is 1 hour plus 0.2298 times 60 minutes to figure out how many minutes that is. And so 0.2298 times 60 is about 13.78, so about an hour and don't restart now. No. Wait an hour. Okay. And 1 hour and 14 minutes. So we're going to add that to 6 p.m. plus 1 hour and, no, minus, sorry. Not adding. It's been dead for an hour and 15 minutes from 6 p.m. Come on, go back. Toot. One more, there we go. 6 p.m. minus 1 hour and 14 minutes. Minutes. And that'll give you 4:46 p.m. All right. You want to know what formulas you have to memorize? That'll be on the PowerPoint tomorrow. I know you don't have to memorize Newton's law of cooling. And then honestly, I don't remember what else you have to memorize. I think all the rest of them, but for sure will be on the PowerPoint tomorrow. I did not look that up, sorry. Domain and range of a log equation without graphing are we supposed to graph? I find it easiest to graph it to figure it out, Nathan, by looking at the graph. And it's always, your domain, if you're talking about a log function, your domain is always going to be greater than the asymptote, right? And then your range will be all real numbers. So, all right. Page 464, number 1. Okay. So they want you to prove that log base b of m to the power of r is equal to r times the log base b of m, using the properties of logarithms. Okay, so let's see if I remember how to do this. I'm going to let, what am I going to let? I'm going to let u, if I let u equal, there's just a little trick. Before we did, if I let, let's see if it's this, let u equal log base b of m, then b to the power of u is equal to m. Yeah. I feel like that's not right. Hold on. I don't want to mess it up. I could stumble through it and figure it out, but this was page 464. So I feel like that's not how you start it. Oh, Mom. Don't tell me I didn't do this problem. Apparently I didn't. That's fantabulous. Scooper. Okay. One more second. Yeah, I'm good. Okay. Okay. All right, so we've got, I'm going to let u equal the log base b of m. That's how we started the other one in the notes too. Go around the world, you'll get b to the u is equal to m, which means that if I take b to the u, well, if I raise, I've got b to the u equals m. And if I take both sides and raise it to the power of r, then I'm going to have b to the ur is equal to m times to the power of r. And now if I go and I take log of both sides, log of b to the ur is equal to log of m to the power of r. And both of these I'm going to do base b, by the way. Log base b of b to the ur. And I do that so that then I can say, okay, well then that means ur, because log base b of b cancel out, is equal to log base b of m to the power of r. So close, I'm almost done, because right now I've got log base b of m to the r, log base b of m to the r. So I've got my left-hand side on that one. I just need to change this guy to be r times log base b, but I know that u is log base b of m, and I'm going to replace the u with it, and it's u times, so that means this is r times log base b of m is equal to log base b of m to the power of r. And there you go. It's flip-flopped, but it's the same thing. Okay. There's that one, and then page 460, number 5. Okay. We've got solve. Solve the equation 4 to the 3x is equal to 2 rad 2. So I know you can use logs on this, but you don't need to because these are both powers of 2. 4 is 2 squared. And 2 rad 2 is 2, I'll break it down. It's 2 to the power of 1 times 2 to the power of 1/2. And if you remember to keep the base, add the exponents, it means that this side is 2 to the 1 plus 1/2. Which makes it a 2 to the 3/2 is the power on that side. And then this side is a 2 to the power you're going to multiply. So 6x. And when the bases are the same, then you can set the exponents equal to each other. 6x is equal to 3/2. And then dividing both sides by 6, I'm going to write it as times 1 over 6, which is the same thing as dividing by 6. So that I can see that, oh look, 3 goes into 6 2 times, and so your answer should be 1 over 4. Yep. All right, that's that one. Can you do the word problem with the half-life from the quiz? Okay, so 15. Quiz number 15. All right, so it says, I have no idea how to pronounce that. Honganinium? Whatever. That thing is a very unstable substance, probably because of the way they said the name of it. With a half-life of 45 minutes. Okay, so half-life formula is your ending amount is your starting amount times 1/2 to the t divided by h, where they give you that the half-life is 45 minutes. And if you have 60 grams to begin with, okay, that's your starting amount. That's A naught. 60 grams. How much is left in 4 days? So T is 4 days. So here's the problem is that these two guys need to be, T and H need to be the same units. So you certainly could change minutes to days, but it's definitely easier to change 4 days to minutes. Yeah, and so we know 24 hours in a day. So I'm going to take that guy. And then I know that there are 60 minutes in an hour. And so I'll take the 4 times the 24, and I'm converting hours to minutes now, and there's 60 minutes in an hour. All right, and so that means that your time is going to be, whatever that thing is, well, let's see, it's 5,760 minutes. Okay. And so how much is left in 4 days? All right, well, you just plug all these in. A is equal to, A naught is 60, 1/2 times 2 times 1/2 to the power of, T is 5760 half-life is 45. And so you end up getting, make sure you put this in your calculator. You should definitely be doing the exponent before the multiplying. Your calculator will do that for you, but it's a 60 times 1/2 to the power of 128. And then it's the 1/2 to the 128 and then times 60. And so I got that it was 1.76 times 10 to the negative 37 grams. That's how much after, or how much is left in 4 days. Not much. Yeah. 10 to the negative 37, you're moving that decimal place over 37 spots to the left. That's a teeny tiny amount, yeah? And then how long until 2 grams are left? All right, now it's a different problem. You want 2 pounds left. That's your ending amount. We started with 60. We have 1/2 to the t is what I'm solving for now. Half-life is 45 minutes. Yeah, so my answer right now will be in minutes when I do this. Divide both sides. Remember, the 1/2 to the t over 45. Don't multiply 60 times 1/2. That is completely wrong. Divide both sides by 60. And you'll have 2 over 60 is equal to 1/2 to the t over 45. And then take the log of both sides. I'm going to just do the common log since there's no e in this. Log of 1 over 30 is equal to log of 1/2 to the t over 45. And we do that so that way we can, apparently Mrs. Hopkins calls it the whistle rule. Go whoop. Oop, I couldn't whistle right there. Oh, whatever, I can't whistle today. All right, so you're going to bring that in front and you'll have a log of 1 over 30 is equal to t over 45 times log of 1/2. And then we want to solve for t, which means you'll be multiplying by 45 and then also dividing by log of 1/2. And that's going to give you your t, which I got was 220.81 minutes. It didn't say where to round, huh? No, so whatever, I just left it like that. Okay, that was the half-life one. Page 481, number 6. All right, so we've got E, we're solving. Yes, solve. There are the directions. And round to the 100th. Okay, so e to the x over e to the x minus 1 is equal to -6. All right, so what I would do is you're going to multiply both sides by e to the x. So you'll have e to the x is equal to -6 times e to the x minus 1, just by getting rid of the denominator. I'm going to distribute this -6 into both of those guys. That's a +6. Combine like terms. There's 2 e to the x's there, so I'm going to add 6 e to the x to both sides. 1 e to the x plus 6 e to the x is a 7 e to the x, and that's equal to 6. Dividing both sides by 7, e to the x is equal to 6 over 7. Now take the natural log of both sides. X is equal to the natural log of 6 over 7. Oh, and then it said round to the nearest 100th. I think we're going to tell you leave it inexact. That's exact. Leave it, right? But if it's asking you to round, which is what the book said, round to the 100th, then natural log of 6 divided by 7 is approximately -0.005 0.154, so 0.15 is what you would say if it's round. I'm pretty sure we say just leave it in exact, so. Okay, that was page 481, number 6. Next one is chapter 9 review, number 5. What chapter 9 review are you talking about? Was it the worksheet? Was there a worksheet? I think so. Okay, I found it. Okay. Chapter 9, review number 5. Ooh, that's a good one. Okay. So this is the review worksheet number 5, which is x squared times e to the x plus 1 plus a 4x e to the x plus 1 and a minus 5 e to the x plus 1. So I notice that there's an e to the x plus 1 in common to everything, so I'll factor that out. And I would be left with an x squared plus 4x minus 5. And then that should factor also. We have a x plus 5 and an x minus 1. You're going to set each factor equal to 0. And x plus 5 equals 0 and x minus 1 equals 0. E to the x plus 1, never going to equal 0. It's just not going to happen. And so that's never. So that gets thrown out. But solving for these guys, x is equal to -5, x is equal to +1. Double check that your answers actually work in the problem. And they end up working. Your answers were -5 and +1. All right. Let me scroll back up. Okay, that was number 5. Same worksheet, number 17. I've got log base b of 5x cubed over 9y quantity squared, and they want you to write it in expanded form. All right, so expanded form means you should not have any exponents. You should have multiple logs written, all of that. So I've got this division symbol. I'll separate them first that way. So this is equivalent to log base b of 5x cubed minus log base b of 9y squared. Maybe I should have, oh, whatever, I've already done it. Okay. Probably the fastest way to get this done is to go, okay, this is equal to log base b of 81 times y squared. Now to be in expanded form, that means you're even separating a constant from a variable. You know? So I'm going to throw parentheses around there even though it didn't exist before. But you've got a 5 times x cubed, so you can separate those. Log base b of 5 plus log base b of x cubed. Minus, I can separate these guys. This is 81 times y squared. I'm going to throw a parenthesis in there because of this minus sign, because you're going to have to distribute that. So it's a log base b of 81 plus log base b of y squared. The other thing to be in expanded form is you are not allowed to have these exponents on the x here. You got to bring it around front. And this guy, you're going to bring it around front. So I'm going to do that, and then I'm also just need to distribute this minus sign into both of those terms. So once I do that, then I should be done. I've got log base b of 5 plus 3 times log base b of x minus log base b of 81 minus 2 times log base b of y. That's fully expanded. That's a full credit answer. Make sure you don't drop off your base b's. I know they look extra, but if you don't have a b, then you're telling me it's a common log, so it's a base 10. So you definitely have to make sure that you include the little base there, that little b. Okay, so that was 17 on the review, page 450, number 32. All right, whoops, page 4, it actually ends up being on 451, but 32, and it tells you solve the exponential equation that is e to the power of 4x minus 1 is equal to 1. Okay, so to solve for an exponential function where x is your variable, remember e is a constant. E is a constant. There's a button on your calculator for it. It's just like pi. It's a different value, but e is an actual number. And so to get the x out of the exponent, you got to use logarithms. Because it's an e, I'm going to use log base e. I'll even write it log base e instead of natural log. Log base e of e to the 4x minus 1 is equal to log base e of 1. And so then log base e of e, those undo each other. You end up with a 4x minus 1 is equal to, well, log base e is the natural log. But what's the natural log of 1? That's 0. Anytime there's a 1 in that spot right there, then it's a 0. Adding the 1, dividing by 4, and x is 1 over 4. Oh. All right, that was 32. Number 24 on the review. All right, so we got 6 to the 2x minus 2 minus 3 to the 3x is equal to 0. Okay, so what I would do first is add the 3 to the 3x over. So you've got a 6 to the 2x minus 2 is equal to 3 to the 3x. And you're trying to solve for x, and so you're going to use logs. So I'll take the log of this side and the log of that side. Taking the log of both sides of the equation allows you to take this exponent and bring it around front and make it 2x minus 2, notice parentheses around it, times log of 6 is equal to 3x times log of 3. All right, you've got more than one x here, so you can't just, well, that's not true either. Do I do it the way you guys like to do it, or do I do it the way that I've been so used to do? I'm just going to do it my way. All right, I'm going to distribute the log of 6. So you have 2x times log of 6 minus 2 times log of 6 is equal to 3x times log of 3. I'm going to collect all of the x's on one side of the equation, and anything without an x, I'm going to throw it over to the other side. So I'll go 2x log of 6. I'm subtracting 3x log of 3, and I'm adding the 2 log of 6 over to the right-hand side. Once I do that, I can factor out the x that is in common to both of these guys. Yeah. And then x is going to equal, dividing that big old thing, 2 log of 6 divided by the 2 log of 6 minus 3 log of 3. If you need to put it in your calculator, which do you do that? Probably. Make sure you put parentheses around this denominator. You could have cleaned this up too, using properties of logarithms. You could have put the 2 back onto the 6 so that it's a 36. Same thing with down below, and a 27. You could have combined it anyway, but you end up, when you put this in your calculator, you should end up with a 12.4565. You should get. All right, 14 on the quiz. All right, so when Pete was born, his grandfather put $5,000 into a savings account for him if the interest rate was 7.5% compounded continuously. When they say compounded continuously, that's when you use PERT. Continuously is what's telling you to use PERT. A equals P times E to the RT. All right, so he put 5,000 into the account. That's your P. The interest rate was 7.5%. You're going to move that decimal place over 2 places to the left, so 0.075. And how much will be in the account on his 18th birthday? And so that means in 18 years. Your T is 18. So you got A is equal to 5,000 times E to the 0.075 times 18. Put that in your calculator. I got that it was about $19,287 and 1.2. Okay, sorry, I shouldn't have said dollars yet. 1.27-ish, something like that. How do you know where to round? This is money. We do not need to tell you how to round it with money. You are going to go to the pennies, which means to the hundredths spot, right? So this will be my last number that I'm going to include. So the 7 says round that 2 up to a 3. So money is the one thing that we never have to say to you, hey, round to the hundredth spot, because it's just a given. The bank is never going to give you a penny more than you earned. And I want every single penny that I did earn. Like, I don't want the bank keeping 13 cents. No, that's mine. 13 cents may not be a lot right now, but it'll add up over time. So, yeah, money, you always go to 2 spots after the decimal place. Always, always, always. And we don't have to say that to you, and you're still wrong if you don't do it like that. So, other things we need to tell you where to round to. Money we don't need to tell you. Okay, that was 14 on the quiz. Chapter 9 review, number 26. All right, so it says a population grows so that it doubles in 50 years. Determine an equation which describes the population growth curve. So, if the population is 500,000 today, what will it be in 150 years? Okay, so this means that, yeah, all right, well, your ending amount is your initial amount times 2, because it doubles, to the power of t over, this will be your doubling time, and it doubles every 50 years. Like that. And then they want an equation that describes the population growth curve. Oh, well, there you go. That's what it is. I'm trying to see. Yeah, there's your population growth curve. And then if it's 500 today, that's your P naught. And what will it be in 150 years? So when T is 150. All right, so you got P is equal to 500,000 times 2 to the power of 150 over 50, which means that you'll have 500,000 times 2 to the third. Don't you dare multiply the 50,000 times the 2. Nope, nope. You got to go 2 cubed first, which your calculator will do for you if you just put the whole thing in your calculator. This is times 8, which means that it'll be 4 million of whatever it is. People? It doesn't say a population of what, so whatever it is. Okay. That was 26 on the review, 14 from the review worksheet. We've got, okay, so they want it in condensed form and simplified. So this is, well, kind of sort of expanded. We wouldn't allow you to leave the squared on the x in expanded form. Other than that, it is kind of sort of in expanded form. And they want us to write it as a single log, logarithm. All right, so what you're going to do is take this 4 and bring it around and put it as an exponent on the x squared. So this will be a log of x to the 2 times 4 will give you 8. I'm going to do the same thing with the 3. Bring it around there, and I've got log of 2 cubed, and I still have a log of 16. All right, if there's a plus sign in front of the word log, then it's a multiply. If there's a minus in front of it, it's a divide. It goes down below. So this guy's positive, so that means you're going to write the word log once, and a blah, blah. X to the 8th goes up top. 2 cubed goes up top. 16 goes in the bottom. Well, 2 cubed is 8, and 8 over 16 is 2. So log of x to the 8th over 2 is your answer. Number 19 from the worksheet. Well, find the domain and solve. All right, so we got log base 5 of x squared plus 4 is equal to 3. So let's start with the domain. So domain is going to be whatever is after the word log, right? Not the base part, but this is called the argument. That guy must be greater than 0. So for your domain, it's x squared plus 4 is greater than 0. And so then that means x squared is greater than -4. Well, that's all real numbers. This guy is always positive no matter what you plug into x. Plug in a negative, you plug in a positive. It's always going to be, once you square it, it'll be positive, and then that guy is negative, and a positive is always greater than a negative. And so your domain is going to be all real numbers. To solve, you're going to go around the world. 5 to the power of 3 is equal to the x squared plus 4. So solving, we've got 5 to the power of 3 is equal to x squared plus 4. Well, 5 cubed is 125. And subtracting 4 will give you a 121 is equal to x squared. And taking the square root of both sides, and we get that x is equal to plus or minus the square root of 121, which is plus or minus 11. Make sure that that works, because remember, you can't take the log of a negative number. But when you plug it into x squared, when it's a -11, it'll become a positive 121. So both answers work. 11 and -11. All right, that was 19. We're on page 481, number 3. we've got domain and solve. And it's the natural log of 3x is equal to 4 times the natural log of 2 plus the natural log of 3. So for domain, you just want to make sure with logarithms, you want log of whatever base, I'm going to call it b just for right now, of blah blah, right? Whatever this blah blah is, this little box, for domain, that box, whatever's inside there, must be greater than 0. That's what you can take to the bank every single time. Whether the base, so this is a natural log, it's log base e, doesn't matter. 3x, the part that's after it, must be greater than 0. The 2 must be greater than 0. Yay, it is. The 3 must be greater than 0. Yay, it is. So those two don't affect the domain whatsoever. The only thing we're worried about is what can we plug into x and it's still defined, right? And so for this case, it's 3x must be greater than 0. Dividing both sides by 3, your domain is x is greater than 0. You can only plug values that are greater than 0 in this for it to be defined. Okay, now to solve. You want to solve for x. So what you want to do is, I'm going to rewrite these. Well, no, I'm not yet. I'm going to make my life easier and still keep them as natural logs right now. I've got the natural log of 3x. What you want to do is get a log equals a log. That's what you want to have happen. And so right-hand side, I'm going to condense it, write it as a single log. 4 is going to come around and be put as an exponent on the 2. And then, so that's a 16. And then a log plus a log, you can write it as a single log by multiplying them. So it's like that. I got the natural log of 3x. This is the natural log equals the natural log, and the only way that's true is if their arguments are equal to each other. You can also see it by if you raised both sides e to the power and then e to the power, the natural logs will drop off. But the other way is if you have a log equals a log, their arguments, those guys must be equal. And so we have 3x must be equal to the, what's 2 times 4 times 3, 2 to the 4th times 3. 2 to the 4th is 16 times 3 would be 48, I think, hopefully. And then dividing by 3, x is 16. Okay. There's your solution. Double check that it works, right? And sure enough, you can take the natural log of 3 times 16. It's a good answer. All right, that was 481, number 3. Have I caught up to y'all? I sure did. All right, talk to me. We got a few more minutes. And plus I started a couple minutes late because my husband's a chatty Cathy. I'm going to be quiet. No more questions? I'll wait for you. Talk to me. Did we do all of your word problems? Oh, we could do that last word problem on the quiz that we haven't done yet. But Anna asked me to do all of them, and I've done 3 out of the 4. So while you're typing, I will do that one. The quiz number 16. Says you decide to take the M&M speed rapping course. You start at 70 syllables per minute, which is urban. I have 0 clue if this is even true. After 4 weeks, you can rap at 200 syllables per minute, which is hip hop. Find an equation to model this exponential function. So we gave you like, hey, use this equation, P equals P naught times e to the RT. All right, so you start at 70, you end at 200, and 4 weeks in between. And so the first thing I want to find is, what is that rate? So I'm going to go 200 equals 70 times e to the r times 4. Dividing both sides by 70, that'll give you a 20 over 7 is equal to e to the 4r. Taking the natural log of both sides, since it's a base e, will give you a 4 times r, and then dividing by 4, I'm just going to write it as 1/4, times natural log of 20 over 7 is equal to your r. And so if that's true, that means your r is approximately, I'm going to 4 decimals again, 0.2625. And so the equation to model, I had lots of different answers on the quiz on these ones when we're asking for equation to model. Keep in mind you should only have 2 variables, right? I should only have 2 variables. I'm going to have p as a variable. I'm going to have and t as a variable. Those are the only 2. I found my r. My p naught was 70, and it's e to the 0.2625, and then times t. Notice that t is a variable, p is a variable. I'm able to predict well, I used p, but it's not really population, is it? I can predict the speed, right, given a time. So that's what, remember, e is a constant. E is not a variable. T, you've got a variable there, and p. So when you give a model, you should only have 2 variables in your answer, period. Period. All right. How long before you can wrap 300 syllables per minute? Oh, now you're going to plug in a 300 in there. E to the 0.2625t. Dividing both sides by 70, you'll have 30 over 7 equals e to the 0.2625t. Take the natural log of both sides. 0.2625t. Dividing both sides by the 0.2625. And t is equal to that, and so I got t is about, I got 5.54, so I said about 5.5 weeks, something like that. All right, 16 and 17 from 482. Yep. And then that'll probably do it. Page 482, number 16, is 4 to the x plus 2 is equal to 5 to the x plus 7, and they want you to solve it to 3 decimal places. All right, you've got x's up there in the exponent, so you need logs. Take the log of both sides. And you do that so that you can bring these exponents and go whoop and go. This guy goes whoop. Make sure you put parentheses around it. I've got an x plus 2 times log of 4 is equal to x plus 7 times log of 5. All right, I'm going to distribute the log of 4 into both of those. X times the log of 4 plus 2 times log of 4. I'm going to distribute the log of 5 into both of those guys too. So you have x times log of 5 plus 7 times log of 5. And then I'm going to collect anything with an x in it on one side of the equal sign and anything without an x on the other. So I've got x times log of 4. This guy I'm going to bring over that way. This guy I'm going to bring over that way. So I've got minus x times log of 5 equals the 7 log of 5, and I'm subtracting 2 log of 4. And then I do that so that I can factor out the x that's in common, and then that way I can divide, blah, blah, blah. So x is equal to the 7 log of 5 minus 2 log of 4 divided by log of 4 minus log of 5. Make sure when you put these in your calculator, you must put parentheses around the top, and then the divided by, and then parentheses around the bottom. If you don't, your calculator will give you the wrong answer. And let me just double check that. We got parentheses, 7 log 5 minus 2 log of 4. Also, your calculator will start, let me put that in there too. Your calculator, when you hit the button log, it'll start a parenthesis here. Make sure you end it, starting, ending it, starting, end, start. Actually, at the very end, it doesn't care. But better to put more parentheses than not enough. Okay, divided by, start a parenthesis, log of 4, end the parenthesis, minus log of 5. Boo, boo, boo. And I got, sure it's right. Yep, I got, it's approximately a negative 38 point, it said to go to 3 decimal places, so 0.063. All right, that's that one, and I think I can squeeze in number 17 real quick since I started late. Same page. Number 17, and that is, again, solving it. So 12 to the x squared is equal to 16 to the 3x. It's a bummer it's a 12 because we can't write them as powers of the same base because 12 is not a power of 2. So you do have to use logs. Log of 12 to the x squared equals log of 16 to the 3x. Bring the x squared around front. Bring the 3x around front. We have x squared times log of 12 equals 3x times log of 16. Really? Okay. So then what? We can do x squared times log of 12 minus 3x times log of 16 is equal to 0. I subtracted it. There is an x in common to both, so I could factor that out. Like that. Set each of those factors equal to 0. So either x is 0 or x times log of 12 minus 3 times log of 16 is 0. Solving for x, x would be a positive 3 times log of 16 divided by log of 12, which is approximately 3 log 16 and the parenthesis divided by log of 12. 3 point, where do they say it around? 3.3473, so 347. So I got 3.347, and also x is 0. So either one of those will work. All right, there we go. Calling it a night. Good luck. I'll see you tomorrow. I'll put the recording in the little window right now. You are very welcome.